We're back live, and it is 11:33. So we'll take a break in an hour. How's that? We'll go for an hour, hour and a half. The most. 11:30, 12:30, quarter to 1. Then we'll break for an hour lunch. How's that? That way you break.
Wonderful.
Huh?
Wonderful.
Wonderful. Perfect. Thank you. That's what I like to hear. Wonderful, perfect, and thank you. Let's talk about something you're really interested in hearing. Well, most people are interested in hearing about the lunch break, but the midterm exam is also another thing people are interested in hearing about. Midterm exam is a take-home exam. There's a link for it right here. If you are brand new, you've logged into and you're looking at your screen, www.bhacker.com. If I go into www.bhacker.com and I look at the first main menu here, I see summer 2011. I hit summer 2011. I see 4 classes that are being taught. One of them is Software Engineering 1. And you also notice the dates are on here. Our final exam will be on July 16th, less than a month away. But you guys are lucky. I'm going to try something new. It's going to be open book, open notes, but closed neighbor. So you can come in with all the notes that you want, all the books that you want, as long as you can carry them in. It is an in-class exam, but it means it's not going to be multiple choice. It means it's going to be like fill in the blank, or it's going to be like short answer. And it'll be okay. So the majority of the grade for this class is on the is on the project. Project's like 55% or so. So we have a midterm that's a take-home, and we have a final that will be an in-class activity. It'll give you something to do. So we'll show up on the 16th here, and we'll all kind of straggle in, and we'll all take the exam. I'll come up with a, between this hour and this hour is this last name, between this hour and this hour, alphabetical order of your last name. I'll break you out into groups. We'll get everybody done in the same day. And I'll give this to you via email prior to the weekend, like a couple weeks. But plan on being here for the 16th. You won't have to be here all day. And you won't have to be here on the 17th, just the 16th. So plan on showing up between this hour and this hour, whatever hour I give you. And if that doesn't work for you, you can always request a different time slot. Although this is a month away, this is not the end of the course. The course ends in August, maybe around the end of August. That is when everything will be due. So most people, I've had tons of people asking me already, is everything due on the 16th? Seems like it's like next week. It seems very close, actually. It's less than a month away. The way that they scheduled this course was kind of odd. We got May, we got June, and we got July. It's over with before August starts, and like the term doesn't end until the end of August. So some people just register for this course, and it's like, well, we have to turn everything in within a month. No. So just to reiterate the point, nothing is due until the very end of the course. The course doesn't end until the end of August. The TA will be sending out a message. So make sure you get on the TA email list if you sign the roster. Hopefully you're in the EMS. Hopefully you're registered for a course and you have access, and you'll get on the email list. If you don't, send me a message. If you haven't heard anything, send me an email message to bhacker@itu.edu, and I'll put you on the email list so you can receive the notifications. Because I want to know when you have to show up for your final, what time. You know it will be on the 16th. You just don't know what time yet, and what the content will be. So I'm going to write a brand new final. It's just going to be the final for you guys. And it will be, I don't know. I don't know yet what it's going to be. I might have you do like an entity relationship, draw a data flow diagram or something like that. We'll see. I'll see what the content is when I write it. But it'll be different, and it'll be open book, open notes, which would be really cool. So you don't have to worry about stressing about studying, memorizing stuff. And then you'll have till the end of August to turn everything in. Your project, your midterm exam. So let me talk about the midterm. You can click on here. You see summer 2011 midterm exam. It's a take-home. If you open the file up, I've downloaded it here. It looks like this. If I make it bigger, let's make it a little bigger. Bigger. It's got 1, 2, 3, 4 short answer questions, and 1, 2, 3, 4 multiple choice questions. So you download the file, you fill it out, and then you upload it to the EMS sometime before the end of the class. You don't have to write a novel for each one of these questions. You know, for example, number 1, describe the processes involved in the complete software development life cycle. SDLC, software development life cycle. List at least 4 major stages and phases, or stages/phases. You could talk about the waterfall model. You could talk about the spiral model. If you don't know what the software development life cycle models are, go back and look at the first weekend lecture. That's where I discuss all those concepts. So, you know, you could probably write 100 pages on that if you wanted to. You got, you know, or enough room in the form for about 2 paragraphs, maybe a paragraph. You know, so answer the question, but, you know, give me a paragraph or something. If you write complete sentences, I'll understand what you're saying. It's open book, open notes, but it just, basically I'm just trying to see, do you know what a software development life cycle is? You know what its 4 typical phases are? Requirements, analysis, design, implementation, prototyping, stuff like that. And then, you know, this question here, you know, why do software engineers create or use models? They could be software development lifecycle models. They could be systems models, any models. In fact, that's what I've been talking about so far is the use of models today. We have data flow model, entity relationship model. So you can interpret that any way you want. Now list 3 types of software engineering models and explain why they're useful. You know? So it's more of a checkpoint kind of, you know, did we read the material? Did we listen to anything? Do we know what anything's going on? So it's a pretty easy test, long story short. So I'll let you go through the rest of the questions on that.
And what is the due date for this exam?
The due date will be the exact last day of the class. It will be due along with the project.
August?
Yeah, August 30th, something like that. But you know, I probably want to do the midterm before you do the final, I think.
Yeah.
You know, I wouldn't wait. Here's why I said the due date, because some people like have just joined the class today. You know, some people, and if you just joined today, you might not be able to do it by 2 weeks from now. Especially if you want to catch up. You know, what is this requirements? What are these analysis stuff? So it might take you a couple of days or weeks or something to get into the swing. Oops, I already talked about data flow modeling, didn't I? So I already talked about that one. Let's see. We talked about entity relationship. Yep, entity relationship's gone. Out the window. It's gone. So, object-oriented analysis. Everybody's favorite subject is the next topic. I got like 3 lectures on object-oriented analysis. So this is just the first part of it. So we'll start in with the concepts, and then we'll break for lunch, and then we'll review the concepts afterwards. So, and then some people are taking the Unix course right now. Juggle it on your own. Sign the attendance roster for both and juggle back and forth. So we're here today and gone tomorrow, so you could stay here and then go to Unix tomorrow if you wanted to. That would be a good idea as well, if you wanted to do it that way. So up to you. So, any questions or anything before we get started? So the midterm you download from bHacker, you fill it out. Hopefully it'll be in the EMS soon, but don't wait for it. Just get it from here. Upload it into the EMS when you have it completed sometime before the end of the course. And we'll send an email message out. I'll have to meet with the TA here. You'll send an email message about the midterm sometime announcing. I don't know the exact due date yet because I don't know when the last day of the term is yet either. So that'll be sent out to you. Any other questions or anything? Pushing right ahead. Oh, we have a question.
Can you tell us about the project?
I would bore everybody here silly. I have talked about it at least 3 times already, but unfortunately this is the first day you've probably shown up. Go back and look at the recorded videos from 521. There's 3, oh, I don't know, it's 3 2-hour videos. It's about 6, 7, 8 hours worth of video. The first 2 are the most important. The first one goes over the syllabus, goes over the project, goes over all of the deliverables, the templates, and everything. And so I don't want to bore everybody else, but that's what we did last time. So, yeah?
We can use a different template or
I would prefer that you use the templates that are in the software engineering notes. The requirement specs on 24, I just showed you today, the 46, page 46. After lunch, we'll look at the design documents, and we'll look at the prototype specs as well, so I can give you everything you're going to need. Everything you're going to need to know to complete the project I'm giving you today. So, but I'm obviously not going to go back to the requirements at this point. Where are we? We've done the requirements document, hopefully. We're doing our analysis. So we're performing our systems analysis. We're performing or creating the design document. As I mentioned before, we're doing this analysis document, but it doesn't exist in the real world. It's our preliminary. It's our first draft of the design, if you want to think of it that way. And then the project will be done. So on page 46 of the class notes, I showed you before I started the data flow and before I started entity relationship this morning. If you were here at the beginning, we looked at the template when we went through the sections. This is what I'm still talking about, but now I'm switching to object orientation, which is interesting. So we've already covered entity relationship, data flow, data actions, and how everything is kept separately. Now we're going to put them together. So object-oriented analysis and design, what is that all about? So it's different than structured analysis, and it usually follows second. So usually people will do the structured analysis first if they think they're going to take an object-oriented approach to the implementation. And we don't know till we analyze it what approach we're going to take. It's not always an assumption because object-oriented languages exist that we're actually going to pick that one out to use it. We might pick something else. So if we're looking at object-oriented, we're going to probably end up doing some object-oriented analysis at least and some design work. So we have two phases. We have analysis and design. When you take a programming course, you usually work with the design component, and you're generally making object diagrams or class diagrams, and you're implementing classes is what you're doing. And there's an entire breed of analysis that also works with the design. That a lot of people, when they take a programming course, it gets skipped for some reason. So it uses structured analysis. Object-oriented analysis uses structured analysis. So it's the visual representation, similar to structured analysis. It documents diagramming built from entity relationship and data flow diagram concepts. And as I already mentioned before, the ERD diagram, the first one we looked at, translates identically to a class or an object diagram. The data flow doesn't translate though. So easy to learn. UML standards are common sense usually. In terms of the methodology, it came about as a reaction to shortcomings. So we have data over here, we have processing over here, we have no way of putting them together, which is the shortcoming. So object-oriented analysis came around and said, well, put them together. And let's show sequences and activities and use cases and all this other stuff, which is what I'm going to introduce to you now. And it kind of gives you yet another vision, another look at it. So the problem with larger projects is putting it and seeing the big picture. So UML actually allows you to see it. The data and the actions are treated as equal partners instead of being separated out. The object consists of data. We've seen that already. And we actually know what an object is because we talked about entities. Those are objects. And so we have the data, the attributes. We have the states, the instance variables, fields, data members, and we have the action that's performed on the data, which would turn out to be methods or messages or things of that nature. And then we have the objects that are independent units as a concept, which is the entity. So we have conceptual independence, and we have the physical independence of these objects as they're put forth in terms of the diagramming. Different methods. Many different methods exist. There is absolutely no standard and no uniformity among any of this, which makes it in fact, everyone, if you go out on the street and you ask people randomly, is object orientation standard? Oh, yeah. It's not. It's not a standard methodology. It's, there's so many different, and there's contradictions in it as well. And then it's one of the most misunderstood concepts out there. It's implemented differently. Just take and look and compare object-oriented programming languages. C++ versus Java. Classic example. They both have their separate interpretations of object orientation. They both follow different rules. They have just there's conflicting implementations in terms of the same concept. So it tells you right there's no standard to it. Brock, he's actually pretty good. He's and this is actually sort of in the order of precedence in terms of who's the most popular and what's the most widely used. These guys down here, both of these guys here, Jordan, he's the entity relationship diagramming guru. This guy, that's just these two guys together. These guys here, you'll see when you go into the tool sets at Visio or some of the SmartDraw, you see Jordan's. You know, you go, oh, you know, okay. Like he's been doing this for years. Assist structured analysis and design, and he's recently kind of got into object orientation because it's based on it. So, and it's just an extension of systems analysis and design. So, I don't know if Object-Tree or OOA, yeah, it's okay, but these guys are the front runners right now. All you have to do is go look at books and you see the authors on there. All these are different methods. Very similar, but there's different object-oriented analysis and design methodologies. Just the same way as there's different software engineering methodologies. They're all essentially equivalent. Now we represent object-oriented analysis using unified modeling language. This is where this UML comes from, and that's a generic term. Unified modeling language. Brings all of these guys together, all of the methodologies together, and creates some standard diagrams. So let's say we're going to do some object-oriented analysis. So what do? Well, we got different categories, and these are 3 steps, but they're not necessarily taken in sequence, which is interesting because you can start with object-oriented analysis from different areas, and there's no step-by-step approach to it. There's no sequence like there was in structured analysis. And if you remember in the beginning, I said structured analysis, they always start out with an entity relationship and a data flow diagram, and then you build diagrams on top of that. Context diagrams, sequence diagrams, all sorts of other things. Because once we've outlined the data, once we've outlined the processing, now we can put it together. So a lot of structured analysis folks start going, let's do the basic DFD first, and we do the UML next, which is what we're doing in our projects. So on the bottom underneath, well, the rest of the stuff you're doing, you're going to put together a use case model. You're going to put together a class model or a dynamic model or something. These are just different areas. So let's talk about use case modeling because that's one of the easiest things to kind of think about. Those are referred to as scenarios, use case scenarios normally. So you determine how the various results are computed by the product without regard to the sequence. It's not a sequence diagram. It's more of a function. Largely action-oriented, but it's not an activity diagram either. It's interesting. We have class modeling, another area, or object modeling. There's your entity relationship. If you've done that already, you've got your object. You've got your class model. You don't have to redo it. Determining your classes and their attributes, purely data-oriented. If you think about that entity relationship diagram, all I've been saying is it's data, data, data. It's, you know, it turns into the database. Well, so does the class model. That's the data component. It's data-centric. And then we have the dynamic modeling. That's process-centric. That's our data flow diagram, actually. But we don't have an equivalent of a data flow in a UML, which is why people still do the data flow. But instead now we have purely action-oriented performance of each one of the classes. Purely activity, sequence, actions that are being performed end up in the dynamic modeling category. And then we have an iteration that occurs, so we revisit these steps over and over again. So this lecture is pretty much going to go through, which is why it's kind of short and sweet. We'll go to lunch probably earlier than I expected, only by 12:30. And I'm just going to overview each one of these different areas to kind of give you a feel for the diagrams. I'm actually not going to go through as much detail with the different types of diagrams because there's hundreds of them. I would sit here for weeks going over all UML. You could take an entire course in UML and not learn it at all. You can take many, many different classes in object-oriented analysis and design and still not learn it all. It's just not something, it's too big, too complicated, which is one of the disadvantages of using the approach is it's hard for people to understand and get to speed with. So, use case modeling. Here we go. We got a user, we got an elevator. So here we have a use case. It's a generic description of the overall functionality. The user presses a button, elevator button, or presses a floor button. Elevator button says, yes, I want to use the elevator. You walk up to the elevator, press it, turns usually green. Why do they turn red these days? I don't know. Red is like a stop, right? It should be green. Well, actually, when it's here, the button changes to green. Oh, we're here, we're ready to go. It's red. You have to wait for the button to turn green before the elevator arrives. So that's user interfaces. So use case scenario, you'd think it would be the user interface, but it's actually the functionality of the system. We have a button for the elevator, we have a button for the floor. It can be used for a lot of different things if you think about the concept. We can say, when the user presses the button, we want it to turn red, we want it to turn green, which would give us our user interface design, sort of. It also gives us our functionality. Also gives us our sequence if you think about it. User presses button, then the user does this, then the user does that. So it's kind of a lot of different concepts, and you can kind of see the power of that. It shows you a lot more than just an E or D or DFD does. So you get comprehensive insight into the behavior of the product based upon what's called a use case scenario. People who do testing love this because this comes out with our what's called use cases. So that is a use case model that uses scenarios. A scenario is nothing more than a list. Like number 1, user A presses the up floor button at floor 3 and requests an elevator. User A wishes to go to floor 7. Scenario-based, capturing the events in terms of which can turn into sequence, actually. And normally used together with use cases in terms of the modeling component turns into test cases side component, because this turns into if we're going through this, we can easily generate test cases out of this. So we can use it in multiple parts of the software development lifecycle, which makes it popular. Anytime anyone can reuse something in different stages, popular, because you don't want to go through the hassles of creating something that's a throwaway. You just use it once. Class modeling, another breed. So we extract the classes and their attributes, and we represent them in an entity relationship diagram. Oh, you've already done that. We've actually already talked about class modeling. So we've actually covered everything in terms of objects and classes. So you deduce the classes and the use cases and their scenarios. Often many scenarios exist. We have a couple of different ways of doing this. And this is the UML approach to it, is to do some noun extraction or to represent it in terms of a CRC or another type of form in which we need a domain expert to kind of look at it and go, well, what kind of things will we come out of here? If we look at noun extraction as a kind of a starting point, we can have a problem definition. We define the single sentence. Well, we have that already. We have the requirement specification document. It's nothing more than sentences describing our system. So obviously this starts after your requirement spec is created. And as an example, buttons in the elevator and on the floor control the motion of the N elevators in a building with M floors. That came from our requirement spec. So then we can kind of extract out the nouns and say, identify all the nouns in this informal strategy. Well, nouns would be button, elevator, floor. We pulled it out of here, movement. And we can create classes out of here from the nouns. Let's say now we have an elevator and a button. And I don't follow this, actually. I hate doing noun extraction, and I think it's junk science. But some people live by this. I only say it's a matter of way of expressing something. A lot of people use more words than they should, or fewer words. How are you going to make a precise list of classes out of that? I usually just look at it and go, noun, noun, the elevator button. Okay, that sounds like 2 classes, 2 objects that come out of that. And then the first iteration of the class diagram might look something like this. And here's the problem with the whole thing. We have information that's not necessarily represented. We don't have any controllers. We don't have any information about, well, what's controlling all of this? We're going to need more. So the first iteration says, well, we have a button up here, and we have an illumination on the button. Is it red or green or whatever? Is it illuminated, turned on, or off? Because usually the thing's off until somebody presses it, but it turns a color. And then we have the elevator button M that communicates with an elevator. And we have floor buttons. An example communicates with an elevator, some sort of an elevator itself as a boolean. Is the door open, door shut? Is it moving? Not moving. So you need an additional class, elevator controller, which you didn't get from the nouns, which is why I don't really like the noun kind of extraction problem, because you're never going to get everything anyway. So the second iteration of this says, okay, let's put the controller in here. So now we have an elevator controller here. Kind of looks, though, if you look at these diagrams, it sort of looks like entity relationship, but it's missing the relationships. So if you already have this, just pull the relationships off. You have the class diagram already. What's an object diagram? It's the same thing as a class diagram. That's the problem with UML. A lot of the diagrams are really the same diagram, that just has a different label and a different focus to it. What's an object? Well, it's a description of an entity. What's a class? It's the implementation of an object. Classes and objects are the same thing in the concept. But a class diagram, in this particular case, now we see the difference here. We have 1, 2, 3 sections, as I mentioned before. One of them is the identity, the button, the states, illuminated, Boolean, true or false. And then the section that's never filled in anyway on a class, the bottom, the messages that go back and forth. If you fill it in, you might as well just write the source code because you're writing the implementation of the class, essentially. But you will see people putting in methods down there like get floor, set floor, and things that are essentially are functionality that are being represented. But yeah, you can easily translate an entity relationship diagram into this particular one very easily, especially if you're not even using the diamond symbols for the relationships, you're just putting the lines in. So. And it's kind of deceiving because you see this little arrow. I probably should edit the slide set, take the arrow out, because there's no really direction. There's no directional flow here. It's not a data flow diagram. So that arrow is kind of misleading. And then there's only one arrow in the whole thing. So that's a mistake. So in the second iteration, we decided to add the elevator controller. On the third iteration, we decided to add, what do we add here? Elevator doors to this. What we ended up happening, and you don't really have to follow the logic of this elevator to know what's going on, we're adding classes. We got we started out with 4 classes. Now we got 5 classes. Now we got 6 classes. We start supplementing, and we start adding stuff in. Where do the nouns come from? There's no nouns anymore. Or we actually eventually have to go think about the process, and we have to actually look at the functionality. Interesting thing is we're starting to see cardinality in here too. This is, you could take this and work backwards, turn it into an entity relationship diagram. We have 1 to 1, 1 to n. We have one elevator controller that controls any number of elevator doors. We have one controller that has many or any number of elevator buttons. That's what the M's and the N's stand for. It's the same terminology used for entity relationship diagrams. Actually, it's the same concept. It's showing cardinality. So you put the cardinality in. Looks to me like a entity relationship diagram.
What's
Yeah.
the significance, M and N? Can they coexist or?
In this particular context, the M and M are referring to N for the motion of N elevators, the number of elevators that exist in the floor, with M floors, any number of floors. You might have many floors. We don't know exactly how many floors. When you build a building, the elevator controller has to work with many different floors. But it might have any number of buttons. There's probably a discrete N. When you use N for any number, usually there's an ending point. There's like seats in a bus. There's a maximum. M, you may not necessarily, they might build another floor. They might have a 15th floor or a 16th floor. Some buildings have 12, some buildings have 20. That number varies a little bit, so it's any, many, or any M, many floors. More than one.
I was thinking if you have many, then it would cover the N.
Except for we're talking about 2 different characteristics. We have the floor controls and we have the number of floors. Yeah. Yeah, it confuses a lot of people, the N's and the M's. When you get used to it, it kind of just becomes like a habit. Any number. I like to use numbers instead of M's for many because I'm a list person. But I'm not a list person, I'm a type A person, going back to that. So anyway, you understand the point, hopefully. But 1, 0. I'm not a person who likes 0. You're going to put 0 on there, why have it on the diagram? But it's an assumption that you don't have to have it. It doesn't have to exist. So. Why is iteration needed? Because, well, the method is not yet mature. Waterfall model explicitly has feedback loops, hopefully. So we've added here, and these are basically approaches to cause iteration or to implement iteration into a system that never had it. As an example, the waterfall model. If we don't put feedback in, we don't ever revisit any of the previous stages. We just keep going forward. And rapid prototyping model, we aim to reduce the iteration by coming up, is this prototype ready? Is this prototype ready? We try to find a stopping point, essentially. And at that point, we don't have to go back and we don't have to revisit stages. We already have it set. We've got concrete features that are implemented that the users have seen in the prototype. In spiral, iterative, or incremental development, we have, it's built into the model itself. So iteration is part of the approach as well as a spiral model. So iteration is property of software production for medium, large size companies. And iteration is also a part of the object-oriented world, which never was a part of structured analysis and design. Structured analysis and design was, you build a layout and you build it from the layout. You didn't make changes to the layout. You followed the format. It's like a cookie cutter template that you use to build something with. You don't change the template. So object orientation, you change the template. You just modify the template all the time. It's like, wow, so that was something that was added. CRC Cards, you probably don't need to know that. If you take an object-oriented analysis course for a programming language, you will probably learn a little bit more about this. It's a card. Actually, in the old days, they used to have 3x5 cards, and then they had HyperCard on a Mac. The Apple computer, Mac OS, came out with a software. It was never translated to Windows. It was never used on any other platform, called HyperCard. And it was a bunch of CRC cards. And believe it or not, there's still teachers today that teach object-oriented analysis and design using cards, 3x5 cards. So you pull out a card, and the card's got these 3 components on it. The name of the class, which is the identity. I call it identity, states, and behaviors, because that's more common these days. The identity is the name of the class. The functionality or responsibilities, which loosely relates to the states and behaviors. And then we have the list of classes and invokes, or the collaboration. So CRC is class, responsibility, and collaboration. Thinking that each class should have its own separate identity, and there shouldn't be 2 classes of the same identity. If we have a student, we just have one student, one teacher. And then the responsibility is, well, what do teachers do? Well, they teach classes. What do students do? They take the classes. So we have clear roles between the different classes themselves. And then the collaboration. What kind of information are we sharing back and forth between the classes? A student can only take a class that a teacher is teaching. And that would be a collaborative kind of effort where they'd have to show up on the days that the class was being taught or something, the time or something. So you put this out on a 3x5 card and you lay the cards out and you play the cards together, like playing with cards. You stack them up this way, you stack them up this way. And there's methodologies that you use to organize the cards, essentially. It's like playing solitaire. Solitaire, yeah. It's a way of creating a class diagram. Yeah. Here's what you do is once you have all these cards, you stick the cards out and you create a diagram out of the cards. You lay them out. You go, oh, look at this. This teacher works with this one here. Oh, look, the teacher's TA. Well, TA works with the teacher, who also works with the students. And you see the collaboration, and you put it out, and then you can draw it or take a picture of it, or, there's your class diagram. There's your model. And this is a modeling technique. So the purpose of it is to understand the system. So you put all that out. You put the cards out there. In fact, there was a lady who used to teach object-oriented analysis and design to grade schoolers, kindergartners, with building blocks. In fact, that's the basis of Smalltalk, which was the language prior to object-oriented design, Java. Everyone's familiar with Java. Well, Smalltalk was I wouldn't say it was a combination of Smalltalk and some other languages that went into Java. But in terms of the concept of the implementation of object orientation, but Adele Goldberg, her thing, which is I want to say it's her father or grandfather, don't quote me on this, I might be wrong, was the inventor of Smalltalk as language from Park Place Digitalk. Well, it was originally Xerox PARC, turned into Object Share, I think, right now. But anyway, that's a long, huge history channel. Actually, it's the Discovery Channel. It says something about times of Silicon Valley, or the start. There's a documentary on this, actually, on the Discovery Channel. It's not bad. It's like the history of the Silicon Valley. It was also played on the History Channel a couple of times in the past. But it documents like the whole start of object orientation and the whole start of the Silicon Valley and the high tech and the internet and everything. So It's actually pretty good. Can't remember the name of it right now. But anyway, long story short, she had colored building blocks. You know, like the Tonka blocks, you know, you give the kids the snap them together and stuff. But she just had blocks. And she was teaching the children how to put the objects together to build software applications. It was actually kind of interesting. And a lot of the pre-work that went into that was the foundation for a lot of the object-oriented methodology. Not only the teaching terms, but the whole UML and the whole way we're using diagrams as an example, the class diagram and the CRC approach. Well, the CRC cards were the blocks, and they were different colors, and you put the blocks together to make bigger objects. And you think of the concept, you have this class, and this class, and you're putting them together, and you're connecting them to build a bigger software application out of it that has this functionality, and this functionality. And then we had, well, okay, this is a good model for the classes. Well, what about the controller? So we had model view controller that came out of this as a concept, because we have the collaboration and we have the controller for the collaboration, and then we have the interface to the collaboration. We have all these other little components. We're not going to go over model view controller for this class, but if you take an object-oriented programming course or analysis course, you might hear that word. It's a methodology, it's a model for your class organization. So you can get all of the components to work. It's the glue holding the classes together, and it's the methodology you're using to design the system. And it works with building blocks. I mean, as a concept, you just have different types of blocks that you're putting together. You know, you have a bridge box, you have a controller box, and you're putting them all together. And you're building an object-oriented programming language out of this implementation of this. And believe it or not, that's object orientation. It's simple. It was a language that, you know, kindergartners can use to write software programs. I mean, and some adults have a problem learning it, but which is kind of interesting. And it's not quite that easy. I mean, there's a lot of different complexities to it. But in terms of, can you shut that door for me? Because the noise is just irritating me. No, the door to the classroom. Could you shut the door to the classroom? Yeah. No. Shut the door to the classroom. Yeah, thank you. Anyway, long story short. No, I don't like the distractions. Anyway, what we're looking at is something like this. This is the CRC card. This is nothing more than a class. And here's the three sections I was talking about. We always have our identity. And the identity is, this is the controller class. And these are the responsibilities, and these are the collaborations. The responsibilities end up being the information that we're holding. Turn on the elevator button. Well, that's going to be a Boolean. Is the elevator button on or off? And we're going to store this data. Now turn on the floor button. Floor buttons, are they on and off? And then collaboration is, you know, which classes are they working with? And this is the connectors that we're building on these little pieces that we're putting together. And it says, well, this is going to have to work with. It's going to have to collaborate with the elevator button, the floor button, and the elevator class. These are the classes that it's going to be working with, which means it's going to be sending messages back and forth to these classes. Where this concept of messages comes into play. So in object orientation, we have a bunch of classes, and the classes store data about themselves, and they send messages back and forth between other classes. Well, that's our CRC, class responsibilities and collaboration, in theory. And that's your introduction to classes, believe it or not. Nothing much. People always think, classes. They're not actually that complicated. It's pretty simple. Objects are pretty simple as an entity. So dynamic modeling. This is where object orientation differs significantly. Everything is static, stationary, in the structured analysis and design mode. If you think of the programming techniques, you don't have to know anything about programming to understand what the old style programming was in terms of structure. The word structure right there tells you there's we started out with line numbers. We started out with procedures that start at the top and end at the bottom, and they always go in the same format every single time you run that program. That's structured. That's predictable. That's static. It never changes. Object orientation, in terms of the methodology, allowed changes. We don't always go from point A to point B all in the same direction every time we run that program. We have event-driven activities. We have user-driven activities. We have all sorts of different things that mess up the structure. So type B people like object orientation. It's not as structured. So we have dynamic modeling that came out of that in UML. We had the ability to model this moving environment, right? So we produce UML state diagrams. State diagrams shows us how things can change into, because there's an infinite. There's not an infinite. There's a finite number of states that program can logically go into. You know, there's only so many numbers of sequences of ways that people can click on a button or use something. So dynamic modeling encompasses state, event, predicates are distributed over the state diagram itself, and here we go. This is where people go, oh no, I knew object orientation, I knew UML was hard. It isn't. This diagram is just ugly. This diagram is showing you, and don't bother even reading it. It's the elevator. This is the elevator event loop. This is determining if a stop is requested, going to the wait state, going to the closing the elevator door. Here's the floor button is turned off now. And it translates into this state goes to this state, goes to this state, goes to that state, goes to this state, goes to that state. If you were to map out every single direction you could go in from driving a car from point A to point B, it could get overwhelming. If you pick just one route, it's a lot easier to understand it. So this is a lot more complicated, which gives UML the impression that it's harder, but it's not. It's just showing you a lot more information as well. But it's supposed to be showing you the translation of the classes from state to state, how they're moving and using around. So a little bit on modeling tools, SmartDraw, Visio, System Architect. System Architect was really cool. It was a shareware program, but it's gone, no longer around. I don't know, maybe you find it out there. Do a Google search on download System Architect. If you do, you'll see entity relationship and data flow diagram templates. All the tool sets pretty much have the same templates, and the templates are the tools, the symbols that you're dragging and dropping onto a canvas to create the diagram. I highly recommend Visio though, but it's expensive unless you get the 30-day trial or a 60-day trial. So here's some examples in what you're looking at. In fact, most of the tools, this is SmartDraw actually. Although SmartDraw has disappointed me. In the beginning it was unlimited, then it turned into a 30-day trial. Now it's like a 7-day trial. And this is probably down to 1 or 2 days at this point, 1 minute. But you went in, and this is the interface for it. This is an old Windows looking interface to it, but you saw like flow charts, organizational charts, networks, and here's our software design. So I went, oh yeah, cool, so you can click on software design, and inside of software design you'd see stuff here. Here's our data flow diagram. We basically go, you know, do we want this one, this one, this one? And then it put in the developers, like Jackson's system, and all the different methodologies. Like your teacher was using this one, you can use this one, you know, and it's a symbol set. And you drag and drop the arrows, and you put it on the canvas. Visio sort of works like this as well. You draw this stuff, which is why it was good. And then here, you know, these should look familiar. You know, you got your data stores in here, and your determinators, and your process bubbles, your process bubble with a number on the top, you know, and your entities and stuff. And here's all the entity symbols and stuff for the entity relationship diagram. So it made it kind of simple because you could, oh, there's the symbol I want. Here's how I want to do my cardinality and all your choices that are available to you. And you just drag and drop it on. SmartDraw is still available. Only problem is it's limited, very limited usage, and it puts a big old watermark on the bottom of it. But as I was saying about the watermarks, don't be concerned with it not being graded on your professionalism. So that was really quick, and it was lecture number 7. So let's take a break for lunch, actually. If I don't see some of you after lunch, you can look at these videos. I have a tendency to lose people at lunch. And you can, you know about the midterm already. I already made that announcement. It's not due till August something, till the end of August, and you'll get an email message that comes out. And keep in mind that all of the assignments are due at the very end of the course as well. And you will have to show up on that Saturday, the July 16th, I believe it is. But we'll send a message out about the final exam. And I'll have some more information for you on the BigHacker.com website as well as we get closer. I'm not going to give you it as a take-home. You actually have to come here to take it in person. But it probably will be open book, open notes. So we'll break for lunch. After lunch, what we're going to do is more object orientation, talk about the design document, talk about the prototypes, and then go home. So that's the plan. Any questions? How long is lunch? That's a good question. People are mostly concerned. Here, let me stop my video, though, because they don't need to know about lunch.